Okay, fine. Yeah, today we are going to start about multi-threading. Okay, multi-threading concept is a new concept. Exception handling is completed. It's a new topic again. What is multi-threading? Okay, that before going to discuss about multi-threading, now we'll see what is threads, what is application, what is process. Okay, we'll discuss these things and then we'll go for multi-threading. Okay, normally what is application, what is application? So now let's say I have opened up my word document. I have opened up my word document. This is an application. When it, how it will open? So how it will open? So when I double click on, when I double click on this icon, okay, when I double click on MS Word icon, so internally it will start one process. Internally, it will start one process to open the application, to open MS Word application. Like that, if you are opening of Google Chrome, so how it will open Google Chrome? If you are double click on the Google Chrome icon, it will open that. So like that, if you are double click on any application, anything, any application is a program. So internally MS Word is also one program, Google Chrome is also one program, Eclipse also program. Everything is software. Software means it is a program, collection of programs. Okay. Even application is also a program which is performed for the specific task. Okay. Okay, the application will, what is the use of MS Word? To write something, to save something, and to print some document, like that, multiple things that we can do, right? So what is the use of MS Word? To write some documentation. That is the purpose of MS Word. So like that, Chrome is for browsing. Like that, each having, there is some specific task for each application. Okay, that is the application means. Application is a program which is designed for performing a specific task. MS Word was designed for writing some documentation. Google Chrome is for web browsing. Okay, like that, every application has its own specific task. Okay, now what is process? What is process? Process means like so we are running of some application, or we are running some application in my system. Let's say MS Word is running, right? So what I am doing, MS Word is I have document is prepared. By seeing the document, I am explaining the class, right? So there may be one more, there may be one more thing I can do. So if I am click on Control N, so it is opening up one more document. It is opening up one more document. Or else I can print off one more thing. Okay, we can print also this one, right? So we can do of multiple operations. We can do of multiple operations. Right. So the process is nothing but executing an instance of an application. MS Word is an one application. If you are starting that one, double click on that one, internally one process will start. Internally, one process will start. That will start opening of the MS Word application. Okay, that process will start and that will run the MS Word application. Okay, and let's say if I'm opening of another process, like Eclipse is opened, Chrome is opened. Okay, so the whenever we are opening of any process, any application, so for that process, okay, for to opening of MS Word application, MS Word application, internally inside the operating system, there is separate memory will be allocated to run off this MS Word application. Okay. In the same way, to run off Eclipse, separate memory will be separate memory. MS Eclipse is one process. So to run off the Eclipse internally inside the operating system, so separate memory will be allocated to process this Eclipse application. Right. So the communication between the MS Word and Eclipse, communication between the process, because it has its own memories. So the MS Word has its own memory, and Eclipse has its own memory in the operating system. The communication between two processes, communication between two processes is expensive, is bit complex. Okay. Now let's read it. So process is an executing an instance of application. So double click on that ms word or icon, whatever it is. So it will internally, it will start off one instance, one process will start to opening of that application. We'll call it as an instance. Okay, executing an instance of an application, we'll call it as a process. So for example, when we double click on ms word icon in your computer, so you start a process that will run this ms word application. That process will run this ms word application internally. Okay, processes are heavyweight operations. These are heavyweight operations. Why? Because they require its own memory. They require their own separate memory address in the operating system. So for MS Word, it has its own memory. For Eclipse, it has its own memory. For Google Chrome, it has its own memory. Right? So because of the process are stored in the separate memory. Because of processes are stored in the separate memories. The communication or interaction between the processes. Okay, interaction between the process is expensive or time consuming or complex. Okay, and context switching from one process to another process is expensive. Okay, the communication. Now this is of process. Okay, now coming to thread. Coming to thread is nothing but a smallest unit work of process. Okay, just assume this is one process. Okay, inside the process, this is one thread, this is one thread, this is another thread. Okay, yeah, go little bit up. Yeah, thread is the smallest executable unit of work, smallest executable unit of the process. So a process can contains of multiple threads. So each thread have a small task will be there. Okay, each thread can do of small work. It can do small task. Okay, thread has thread has its own path of execution in the process. So it can the thread in the process the thread in the process it can execute its in own way. Okay, it can execute its own way. And whenever you are starting ms word or whatever it is internally, it a process will create, right? So the process contains multiple threads. Process had its own memory, that memory will be shared by multiple threads. So this process has, in the operating system, it has its own memory, right? So inside this process I have created of multiple threads. So whatever the thread 1, thread 2, thread 3, so these three threads will use the memory of process 1 only. So the communication between threads is easy compared to communication between the process, because these threads will use of shared memory. These threads will use of shared memory. Okay, now let's go to the document and read that part. Yeah, so where we are, yeah, thread has its own path of execution in the process. For example, when you start MS Word application, so operating system will create a process to opening of MS Word, and it will start the execution of the primary thread of that process. Let's say in that process, if we have multiple threads, if we have multiple threads, then one of that primary thread will start the process and then it will open the application. Okay, a process can have multiple threads. That's what you have seen in the below diagram. Threads of the same process. Threads of same process share the memory of that process. Okay. Threads of same process will be using of the shared memory within that process. Okay. Within that process. Now, the threads are stored inside the memory of a process, as the threads are stored in the same memory space. The communication between the threads. The communication between the threads within the process is easy and fast and less expensive. Okay, that's what this one. So the diagrammatically, this is one process, this is another process, this is another process. Within the process, we have multiple threads is there to complete its own task. To complete of its own task, we can create of multiple threads. Let's say assume of that it is one process. Internally, MS Word is one process. So for the whichever I am opened in this file, I am writing something. So for this, it will create of one thread. Okay. Let's say if I'm opening of another thread, if I'm opening up another thread, for this it will open up another thread. If I'm printing off this one, so for this it will open up another thread. It will create of separate thread internally. So all these threads will use of shared memory of the process of MS Word application only. Okay. Now from this you should understood, okay, the process is a separate, it is an executing an instance of an application, it is a separate, okay, and thread is a smallest part of a process, smallest part of a process, it will execute it's in its own way, okay, and communication between the threads within the process is also an easy task, okay. Now let's come down. Okay. Now we'll go for multitasking and soon we are going for multitasking or multi-threading. We'll discuss. Okay. So multitasking is means okay. Multitasking again two types. Now let's see what is multitasking. So if you are executing multiple applications simultaneously, then we can say it is a multitasking. Okay. If you are executing of multiple more than one task, if you are executing more than one task simultaneously at a time, then we can say it is a concept of multitasking. There are two types of multitasking there: process based multitasking and thread based multitasking. Process based multitasking and thread based multitasking. What is mean by process based multitasking? What is mean by process based multitasking means, so let's say already we have seen for MS Word it is opening up one process, for a Google Chrome it is opening up one more process, for Eclipse it is opening up one more process, right? Executing in process based multitasking, so it will execute of multiple applications simultaneously, okay. So because of multi process based multitasking, so in our computer multiple applications are running simultaneously. If system is not supporting by process based multitasking, then at a time in our system I can't run off Chrome, I can't run off Eclipse, I can't run off Notepad plus plus and MS Word. So multiple tasks we cannot perform if our system is not supporting by process based multitasking, okay. Now let's come down. Process based multitasking, see that, or multi-processing. Process based multitasking or multi-processing, both will call it as the same, okay. In process based multitasking or multi-processing, multiple process are executed simultaneously. So we are familiar with this multi-processing, right? Because of this feature only, our computer runs more than one program simultaneously. So sometimes we'll watch the video and sometimes we'll write something, we'll prepare up some document, and sometimes we'll work on in Eclipse. So and sometimes we'll log into the Facebook and we can do of our chatting like that, right? So because of this system is supporting multi-processing, because of that only our system is supporting, we are using of multi-processing. So the real-time example. Okay. Now, what is a thread-based multitasking or a multi-threading? Thread-based multitasking or a multi-threading? Okay. Now, within the process, if more than one thread is working, then we'll call it as a multi-threading. Let's see, in thread-based multitasking, or multi-threading, multiple threads in a process, multiple threads in a single process are executed simultaneously. For example, MS Word can print the document using background thread. At the same time, another thread can accept the user input to write the new document. Okay, like that, it will support of multiple. threads in a single process. We'll call it as a multi-threading. We'll call it as a multi-threading. Let's say for example of let's go and create of how to create of now let's will write of one package multi thread, okay, and dot threading. Now let's say simply if I'm writing of some array, okay, just assume of some 10 you have given, so system dot out dot println of just nothing, just to print it, okay, main method, okay, plus I plus I. So it will execute of 10 times this task. 10 times this loop will iterate and it will print off that value as 10 times. Right? So internally it will create one thread. So even for executing of main thread also JVM it will create of one thread. JVM will create one thread. What is the name of the thread? All those things that we'll see in the coming future classes. Okay, in this multi-threading only. Okay, now how many ways that we can create a thread? How many ways we can create a threads means there are two ways to create threads. There are two ways to create a thread. Okay, if you want to know the current thread, system.out.println of thread dot current thread dot current. There is a method called current. See, there is a method called current thread dot get name. There is a get a name of that current thread. For executing of this main method also JVM internally, it will start off one thread that is called the name of the thread is main thread. Name of the thread is called, let's go and see. It is a name of the, it is giving as main thread. Okay. Now for each and every task, internally JVM also will start off one threads. JVM also uses of threads to start its work. Okay, internally. So we are using of we are running this program. After completion of our program, there is one more thread will run internally. There is one more thread will run in the background to delete the unused objects. So that will be run by JVM. There is a garbage collector. Okay, there is one more thread will run to delete of unused objects. Okay, now we'll see those things practically in the soon classes, in the coming classes. Now there are two ways to create of there are two ways to create of threads. One is by extending thread class by using of runnable interface. One is by extending of creating threads in Java. How to create threads? How to create? First we know what is thread. First we know what is thread means. Thread is the smallest unit of work in the process. Thread is a smallest unit of work in the process. Smallest unit of work in the executable unit of a process. Okay, it can execute its own way. Now first way we'll take it. So by extending a thread class, we can there are two ways to create threads. Okay, there are two ways. One is by extending a thread class. Another one is by implementing runnable interface. By implementing runnable interface, we can get a thread behavior. Why do we need to extend thread class? Means normal class we can create, but that is not a thread. So to create to get the thread behavior, to get thread behavior compulsory our class compulsory our class has to extend either thread class or implement runnable interface. Okay, now for the example, so to create of our own user defined exception, to create our own user defined exception, we are extending some either exception class or runtime exception class. Why we are extending that? To get that class as a exception behavior. To get that class as a exception behavior, we are extending either exception class or we are extending of runtime exception in the same way. Okay, to get the class for our class as a thread class. Our class to get the thread behavior, our class has to extend either thread class or implements runnable interface. Let's take a first example. Let's take one first example. Thread. Let's create a test. I have created one class. Okay. Now this is the class. So to get the thread behavior by extending thread class. Okay. By extends thread extends thread. So if you are extending thread, then this test class is it will behave as like a thread. It will behave like a thread. Okay. Then now, so where is this thread class is available? It is available in which package? Java.lang package. The thread class is available in Java.lang package. It is available. Okay. Now inside the thread so what is the thread? It will do of some work, right? It will do of one work. It will do. Each thread will do of some small work. Okay. Out of one big work, it will do of some small work. It will do. Let's say let's say for example, so to do that work, whatever the work that I want to do, let's say I have some big work is there. I want to divide that work into multiple threads to finish my work as early as possible. To finish my work fast, I am sharing that work into multiple threads. Okay. Now let's start it. So whatever the task that you want to perform, whatever the task that you want to perform, we need to write in the inside the run method. We need to write inside run method, guys. Okay. Now let's start off public void run method. We need to write off run method. We need to write it to get the thread behavior. Whatever the task that you want to perform, whatever the task that we want to perform, we will write inside run method. Then thread will call this run method. We no need to call this method. Thread automatically internally it will call this run method to finish our work. Now let's see. For example, write off some for loop of some 100. Assume of some 100 and system dot out dot println enough. So value of I is value of I is I. Okay. Now this is a my task. Who want to execute this task will be execute by this task will be execute by thread. This run method also will call by thread only. Now let's see how it will call run method means first create of our class object. So this class is a thread. It is extending of thread class. So now create of object of thread class T equal to new thread. For new test class object I have created. Now how I don't want to call directly this method. I don't want to call this method directly. So T dot start. T dot start method if I am calling internally the start method. Actually in the test class I didn't write any start method. This is the method that is coming from thread class. This is the method of thread class, guys. See, it is a super class method. Okay, what it will do internally, the start method will create a new thread, create a new thread to finish off my task, to finish off my task from 0 to print of 0 to 100. So the task for that task, it is the start process. Start method will create a thread. Start method will create a thread, and the task will be performed by that thread. See. So if you want to know that, the name of the thread, system.out.println thread dot current thread dot get name. Get name. Now let's see. See one thread. See thread 0. Thread 0 is created. Okay. There is one. So normally this will who will cause calling of main method? There is a separate thread, that is main thread. For executing of my task, so internally the start method is creating of one more thread. The name of the thread is thread 0. Name of the thread is thread 0. If you want the dot set name. If I want to give of a name for that thread, then we can give as my thread. I'm giving as my thread. Now instead of this, now let's see what is the name of the thread will come. It's giving as my thread. So my thread one name new thread is created to finish off work for printing of 1 to 0, 0 to 100 for that work. So it is created one internal thread. The task of that thread is to printing of or executing of this logic. Okay, now let's go to the document. Extending a thread class. Extending a thread class. So we can create your own thread. We can sorry, we can create our own thread class by extending thread class by extending of thread class of java.lang package, thread class of java.lang package. So if you are extending a thread class, you have to override run method. Compulsory we need to override run method. Okay, we need to override of run method. Okay, and so whatever the task that you want to perform, what is the task? This is the run method. Inside this run method, I have created my task. So my task is printing of 0 to 100. That is my task. Okay, now for that work, we are writing inside the run method only, compulsory guys. This run method is executed by the start method internally. Okay, now if i am if I am without calling start method, then without calling start method, system.out dot no no t dot run method, t dot run method. Now let's see, it will create of it will execute like a normal method. See what is the, it is executing like a normal method, and the name of the thread is coming also main thread. There is no separate thread is created. There is no separate thread is created for to complete of to finish off my task. Okay, if we are calling start method, then only internally then only internally it will create one thread to finish off my work. Okay, and it is not responsible of it is not programmer responsible to call off run method. It is our responsible only to call off start method. The start method internally will call off run method. Okay, it will create one thread, and that thread will call off this run method to finish off its work. Okay, now let's go to the document. You have to override of run method of thread class and keep the task which you want to, which your thread want to perform in this run method. Whatever the task that your thread want to perform, we need to keep the task inside the run method. Okay, syntax of creating thread by extending thread class is this is the one. This is the example. Now let's see, class my thread extending of thread class. This is of run method. So whatever the task that you want to perform, we need to keep inside this run method. Okay, if any task that you want to perform, we can keep this inside run method. That run method will call by thread. So that who will start the thread by using of thread dot start method will create the thread. Okay, now let's, after defining your thread, you have to create an object of our thread class and call start method and call of. So what we are done, we are creating of our thread class. It is extending threads, and we created object of test class and calling of the start method. Calling of start method. Create object of your thread and call start method. So wherever you want, okay, wherever you want this task to be performed. So maybe I can call off this place in multiple places. Wherever that is required, I can create of that class the test class object, and then I will call off start method. Let's say inside the main method, I don't want to do this one. So let's say I'll write off my m1 method. I'll write off my m1 method. Inside this m1 method, inside this m1 method, I'll do off that work. Inside this m1 method, I will do off this work. I will call off one more m2 method. Wherever I want, I can create of that object of the thread class, and then I will call off start method. I'll call off start method. Let's m2 method. Now here also you can do that task. So then in this case, it will call off two times. It will call off two times. See, go a little bit up. This is one time. See, thread 1 is one started, and thread 0 and thread 1. Two threads is started at a time, right? So two times I called start method. For this it will one thread will start, and for this also it will create off one more thread. Okay, to finish off its work. So it will print off two times that 0 to 100. See, thread 1 it is starting, and it is printing off up to let's see, thread 1. No, yeah, it started 0, 1, 2, 3, 4 up to, yeah, up to 6. Up to 6 it is giving of thread 1 priority. Up to 6 it is giving of thread 1, and after that it is giving chance to another thread. So thread 0 is also there, right? For that again it is starting off 0, 1, 2, 3, 4 and 5, 6, 7, 8, 8, 9, 10, 11. Let's see. So after some time, it will give, see, after 17. So before thread 1 is up to 6, it is stopped. So, and thread 0 is started again, 0 to 17 it is printed. Again, it is giving chance to thread 1. Again, it is giving chance to thread 1. So, thread 1 is stopped its execution at 6. At number after printing 6, it is stopped its execution, and it is giving chance to thread other thread. Now, again thread 0 is stopped its printing of the value after 17, it is stopped its work, and it is giving chance to thread 1 again. So, 7, 8, 9, 10, 11 up to, let's see, thread 1 only it is printing. Thread 1. So at some point of time, again it will stop and it will give chance to, let's say, thread 1 only it is executing, and let's say up to 100 it will. Now let's see, yeah, around, yeah, thread 1 work is completed. Okay, 100 is printed, 0 to 99. So and then it is giving chance to thread 0 again. So 17 it is stopped, and from 17 to again it is started to till 100. Thread 0 is also finishing of its work up to 99. Okay, but in this case at a time multiple threads are starting, so some point of time it is taking time and it is completing its work, and again it is giving chance to some other thread, and that thread also will continue its work, and then after some time it will stop its work, and then it will give chance to some other thread. Okay, so at a time multitasking is happening here. This is called, now this is one way. Wherever you want we can call it. Okay, now let's see, this is an example of whatever that we have seen. This is the example. Okay, now next it will print off values from 0 to 9. Now what is the difference between calling of t dot start and t dot run? Just now I told you So compulsory we need to use of t dot start only. If you are calling, it will not create of the thread 0 and thread 1. If you are calling like a normal t dot run method means then it will call like a normal method. It will call like a normal method, not like a thread. Okay, then both will be run by main thread only. Now let's see. See, all are running by main thread only. There is no separate thread is creating for in this case and in this case. Both are using both are executing by using of main thread only, not the new threads. Okay. Now let's read it. In case of t dot start, a new thread will be created. Okay. In case of t dot start method we are calling, it will create a new thread. Okay, it will create a new thread which is responsible, whichever it is created, which is responsible for execution of run method. That new thread whatever it is creating by calling of start method, that thread is responsible to execute of run method. Okay, but in case of t dot run method, in case of t dot run method, if we are calling that, no new thread will be created. No new thread will be created. Run method will be executed just like a normal method. Okay, it's not like a thread method. It's like a normal method. It will execute by main thread only. See, it will execute by main thread only. So, in the above program, we can replace t dot start with t dot run. Then in this case it will also execute, but the way of it won't create of any new thread. It will execute by using of main thread only. Okay, now next case 2. Okay, this is the case 1. Why do we need to call start method only instead of calling run method? Now importance of t dot start, what internally it will do, what internally it will do for every thread. For every thread, the required mandatory activities like registering a thread with a thread scheduler. Internally, thread scheduler will be there. Okay, that is responsible to execute which thread at what time. Okay, it is not a JVM. Thread scheduler will take care of which thread want to execute. If multiple threads are there means multiple threads will be there by. So for some period of out of 10 seconds, yes, this time 2 seconds I will give for thread 1 and I will stop up for thread 1 and I will give up for 2 more seconds for thread 2. Like that, that is everything is depending on thread scheduler. Okay, it is not on JVM. Now thread scheduler will take care of thread. Okay, and whenever you are calling of start method, and program is really responsible just to define the job inside run method. Our work is only to finish our work within the run method. The calling of run method, creating of threads will be taken care by start method. Okay, it's not our responsible. If we are not overriding, if we are not overriding run method, what will happen? Okay, now, so this is of run method we are overriding from. Run method we are overriding from thread class, right? The run method is already there in the thread class. If we are not overriding that, then nothing will print. Just they have written run method, but there is no nothing, just only implemented it, but nothing is happening internally. That see, there is nothing. It's simply the running method, but there is nothing is there. But it is a start method means just a start. Start method means then it will do a lot of work internally. See, it will do of creating a tree. It will create of thread everything internally. See, started everything. It is doing of some implementations to work on that. Okay, lot of internal things it is happening for that, for creating of new thread. Okay, now if you are not overriding run method, if you are not overriding run method, then thread class run method will execute. Okay, if you are not overriding thread class run method, it will execute, which is an empty implementation. Hence, we will not get off any output. That's what happening. Let's say we will take off an example. Understanding of run method. Okay, class A. Just assume I have created of class A, and inside this class I written of M1 method. I written of M1 method system.out.println of M1 method in A class, right? M1 method in A class. Now, if I'm writing of one more class with B, one more class with B, how extend of this class A. Okay, same way the test class is extending thread class. Even class B is also extending, class B is also extending class A. Inside class A, we have a method called M1 method. Okay, inside class A, we have a M1 method. If I want to change of implementation of M1 method, okay, then we can override it, right? We can override it. Wide, just override it. System.out.println of M1 method in B class. Okay, M1 method in B class. Let's create of B class object main method B equal to B equal to new B. Okay, new B. So if I'm calling B dot M1 method, which method it will call, guys? If I'm calling, I have created object of B class and then B dot M1. Which method it will call? It is of overriding concept, guys. Which method it will call? For better understanding of this one, I'm explaining this one example. So A class is M1 method is there, B class is M1 method is. In the B class, I have overridden M1 method of A class. Now I have created object of B class and then I'm calling of M1 method. So will it execute or not first? Guys, what is the output, guys? Doesn't matter. There is a wrong means nothing will happen, right? A class method will execute or B class method will execute? A class method. Okay. Now let's see. Which class method is executed? Yes, we have created a object of B class and then we are calling of M1 method. If B class does not have this method, if B class does not overriding this method in the A class method, both are same method, right? M1 and M1. If B class method is not overriding, then it will call off A class method. Then it will call off A class method. See, M1 of A class. That's what in the test class method, if I'm not overriding run method and then if I'm not there, then it will call off thread class run method. Inside thread class run method, if nothing is there, then inside it is a empty. Just if I'm removing this one, internally it will execute, but you will not get off any output, right? Let's see here. I have not written any statement. So empty output. That's what is happening in case of if we are calling normal, if you are not overriding run method. If you are not overriding run method, so it won't, the thread class run method will execute, but that is a empty run method. Okay, it will execute and it won't print off any output. That's what will happen if we are calling of dot start. Will call of run method of thread class method. Nothing, it will not display anything. Okay, that's what the meaning. For that only, if we are overriding, so we are overriding to create our own task. Okay, if we are not overriding, then default method will be called in the thread class method. Okay, now class my thread extend. So this is one same example. So overriding of run method. It is highly recommended. See, it is highly recommended to override run method. Otherwise, don't go to multi-threading concept. If you are not overriding the run method, there is no point of going to. There is no point of going to multi-threading concept. Okay. Now overriding of run method. Overriding of run method. So we can overload run method, but thread class will start. Thread class start method will invoke always no argument method only. So the other overload methods will have to call explicitly. Now let's say we'll take off an example one more. Uh, let's have a class, test class. Yeah, let's create our own class. One more class, my thread. Okay, extend of let's extend thread. Okay, to get the thread we have, compulsory we need to extend. So normally, if you are extending thread class, we need to override run method. We need to override of run method. Otherwise, there is no point of calling this method, right? System.out.println of run method. Run method with no args. Run method with no args. Let's say I'll write off one more method. I'll write off one more method with some parameter. Hint A. Run method with one argument. Print A. Okay. Now let's create a class thread test. Thread test with the main method. Create object of my thread class. Create object of my thread class. Okay. M equal to new my thread. New my thread. Now if m dot start, m dot start, then it will call off only run method without argument. See, run method without argument method is called off. The start method internet is calling off run method without argument. This method only. If you want to call this method, then we need to call explicitly this one. We need to call this method explicitly. M dot run off some 10 value. Then in this case, it will start. It will call off m1 a run method with parameter. Run method with parameter. We need to call explicitly if you want to call off run method with parameter. By default, if thread want to call means the start method means want to call default method. The start method will call internally. It will call off run method without any arguments defaultly. Okay. The start method. The start method m dot start method internally it will call off run method without any argument. Okay. Run method without any arguments that will be called by our start method. That's what this meaning. Okay. We can overlay run method, but thread class start method. Thread class start method. This start method is part of thread class. Okay. It's not my class, right? In my thread class, I don't have thread start method. That is starting method. The start method is from thread class. The start method of thread class will call. The start method of thread class will call only the run method without any argument or no argument run method will be called. Okay. No argument run method will be called by the start method. So no argument it is called. Okay. Now let's go to document. Start method always invokes no argument run method. Okay. The other overloaded run methods we have to call explicitly, then only it will be executed like a normal method. Okay, that's what this example. See, run method without any parameter, run method with one parameter. We created an object of the mythread class and we are calling of start method. Then it is executing of no arg method is executed. This is the output it is coming. Okay. Now, next case is overriding of start method. Overriding of start method. Start method is of Which start method that is available in? That is available in thread class, right? If we override start method, then our start method will be executed just like a normal method, and no new thread will be created. Okay, if we are overriding that start method, then it is like a normal method. Okay, now let's override in the same class only, write off one start method. Okay, yes, start method. Okay, write off start method. It's not like a synchronized write off start method. Okay, that out that print enough sts dot method of my thread. Okay, start method of my thread. Now let's see. We are calling start method. Then now let's see. It is like a normal method. See, start method of my thread. We should not override start method. We should not override start method. We should override only run method only. If you are overriding start method, then it will execute as a normal method. Okay, then it will execute as a normal method. Only start method only. We should not execute only start method only. Sorry, start method we should not override. Only run method only we should override to get the thread behavior. Internally start method will call off creating by new thread, and then it will call off run method. Okay. Calling off start method again multiple times, what will happen? Calling off run method, what will happen again? Now let's not require this one. Will not get off thread, right? It will execute as a normal method. Now already I have started off the thread, yeah, m dot start. So it will call off thread class start method, and internally it will execute off run method of my thread class, right? If you are calling off again this one, here calling off again this one, then we'll get off some runtime exception like illegal thread state exception. Already thread is in started mode. Again you are trying to run the same. Already thread is in started. Already by calling this one, thread is started, new thread. Again we can't call the start method. It will throw an exception like illegal thread state exception. Thread is in already in running mode. Again you are calling start, then it is a illegal state. We can't call same thread multiple times. Same thread twice. If you are trying, it will throw an exception. See, after starting a thread, we are not allowed to restart the same thread once again. Already started, right? So if you are restarting again same, we'll get off an runtime exception saying illegal thread state exception. Once again, if you are starting, then it will throw an exception, illegal state exception. Okay. Now, the last case. So life cycle of thread we'll see, and then we will wind up the class today. Okay, let's wait, guys. Life cycle of a thread. Once we create a thread class object, okay, my thread m equal to new my thread. Once we create a thread class object, then thread is set to be in new state. Okay, in this time, in this case, the thread is in a new state only. The thread is in new state, or like it is in a born state. Just it is in new state or born state. Now, if we call start method, if we call off start method, then the thread will be entered into different state that is called as ready state or runnable state. Ready state or runnable state. Okay, runnable state. Okay. Now, once let's see the second point. Once we call start method, then thread will be entered into ready state or runnable state. Okay, and if thread scheduler allocates CPU, thread thread scheduler is responsible to execute the task. Okay, if thread scheduler allocates some CPU, then thread will be entered into running state. Okay, if thread scheduler is giving chance to start its work, one which is in ready mode or runnable mode, then thread scheduler will give some chance to start off its work. Then in that case, the thread will be in runnable state, sorry, running state. Thread will be in running state. Next, once it is finished its task, once it is finished its task of the thread method, okay, means run method is completed. The task means then the thread will be entered into dead state. Then thread will be entered into dead state. Once run method is completes, then thread will be entered into dead state. Thread means why run method means, so internally the start method will call off run method, right? So once this run method is completed means then thread will go into dead state. Thread will go to dead state. Okay, guys, is it understood a little bit? Maybe you practice it once again and then revise it the concept, read it. If you are not understanding any points, then we will discuss it again. Okay. So I'm thinking there is no any sentence is difficulty to understand of that, just let me know that I'll repeat that part again. If anything is not understood that, if you are revising while revising it. Okay, guys, that's what for today's class. And tomorrow I'll explain one more concept. That is second way is creating of threads by using runnable interface. That we'll discuss in tomorrow's class. Okay, guys. Yeah. Thank you. We'll meet tomorrow.